Okay, so this is our evening keynote burlesque. But I know, Brian, you can do it. I know you can do it. And as I said, I'm not going to do bios and stuff, but I will say a couple of brief remarks. And that is, when I first came to SFI, I came from the Institute for Advanced Study in Princeton, and I was surrounded by string theorists, and I thought they were the most arrogant, reductive, simple-minded, yeah, imperious, intolerant human beings I'd ever met until I met economists. And in fact, there was a nice, the founding meeting of the Santa Fe, I know, Brian, you're going to mention this, but it was written up. I think it was the meeting that Phil Anderson and Ken Arrow co-chaired. And the article actually has that remark. I sort of stole it, and it says, he's in Science or Nature, and he said, I always thought that physicists were pretty much impossible until I met the economists. But Brian, the reason I'm mentioning all this is Brian is not that way. And he really isn't. And, you grow up, pursue a career in science. We heard this from Ole. You suffer all these travails. And you think the scientists who are basically iconoclasts are going to be, inspiring mavericks. And they're not. They're just boring. And that's why you're at the Santa Fe Institute and not at universities, right? And that's where all of your money should go. And Brian is that original maverick, and he really was. He left his position, I guess, at Stanford, where he was a highly decorated professor. He'd won also Schumpeter Prize and Lagrange Prize, and he came here to remake economics. And I think he's an inspiration for a lot of us, including many of you here. So, Brian, much looking forward to your talk.
Thank you. Well, David, don't forget I get the last word here. Let me see if I can find a clicker. Oh, here it is. Thank you very much. Yep. Yeah, well, good evening. What I want to talk about is whether complexity economics makes any difference, whatever. And the context for this is that quite often in economics, people come to me and they say, you have this complexity economics or non-equilibrium economics, call it what you might, and we're glad it's there. And it's kind of like maybe a luxury, something like in your car that might be a luxury add-on that you can put on to the main car, but certainly isn't the main engine. The main engine is standard economics. And if we're in a pretty good mood, we'd allow one or two thoughts from complexity economics, whatever that is. We're not quite sure what complexity economics is. We're sure enough we don't like it to turn down nearly every paper that anybody here would send in. And by the way, talking about Santa Fe, David, I wrote a paper largely here that I sent to 4 different journals in a row in the 1980s. And it got turned down for 6 years and then was finally published. And it was really on complexity economics, and it's just gone over 10,000 citations. So I think that one theme of what I'm going to say here is that I think we might get the last laugh. But you can see there's a certain amount of annoyance, even bitterness in the history I've had. Let me talk a moment about the economy, talking about technology. I'll give up on this thing. Okay, so the economy, whichever economy you take, whether it's in Europe or the US, it's this enormous set that several speakers talked about this afternoon of trading and arrangements and buying and selling and investing and exploring and strategizing with many different people, human beings, nearly always, but not always, sometimes algorithms, and people trying to figure out things and launch things and shut down things. It's a huge hive of activity. About 200 years ago, economists, including Adam Smith, but he wasn't the only one, started to notice that in this there was a sort of recursive loop. They wouldn't have called it that then, but if you take any part of the economy, what you notice is that all the individual behavior is causing some aggregate outcome. These are now phrases we'd use now, but it'd be slightly different 250 years ago. So there's an aggregate outcome, and then the people in the economy are readjusting and readapting to that. What I want to point out is that complexity isn't new in economics. We've been thinking of these recursive loops. I'm not that old, but we've been thinking about these recursive loops for, well over 250 years or so, and writing about it. And it's a natural way to look at the economy. I'm going to argue that all the activities somehow bring you an outcome, and those activities are continually changing and adapting, and that changes and it readapts the overall outcome. This slide I put together last night, and I thought it's a bit complicated. I want to talk about the standard approach. The payoff is that if you can understand this slide, it's worth 5 years of graduate school in a really good economics department, because this is what they teach you. So let me go through it. You take some situation in economics, whatever it might be. Could be asset pricing or stock market. It might be some insurance market. It might be some auction for radio waves, etc. And we're going to take what's maybe quite a nebulous situation, but step one in this recipe, the recipe is largely due to Paul Samuelson and other people who preceded him. And the recipe is quite sensible in a way. It gives you a scientific approach. So you define some situation as a logical problem. That's where you start. And then you assume all the agents. They might be consumers, they might be investors, or they might be firms. You assume each category of agents has identical agents. That simplifies the mathematics a lot. In fact, it makes it all possible. Those agents are behaving rational. Rational means they can do an infinite amount of logic. Now, it might take you 6 months to figure out how this problem works as an economist, but the assumption is that the average human being in this situation does it instantly and naturally. So that their behavior together produces some outcome that in turn validates that behavior. It's a kind of finesse, if this were in some game or card game. It's clever because you're saying we have to simplify somewhere. So we're going to look at situations that are logical, identical agents. These agents themselves are logical. So if they're in some complicated thing, they will do the rational or optimal thing. Together, that'll produce some outcome. And we're only looking at outcomes and behavior that are in equilibrium, that aren't causing things to change anew. Notice a couple of things. These aren't quite steps, but more footnotes at the bottom. You've mathematized the problem. You've taken it, you've made it mathematical. This all came in around 1870, 1880. And Eric Beinhocker earlier today mentioned Valrat, the French engineer, actually, who worked in Switzerland, who brought quite a bit of mathematics into this. Moreover, the solution's an equilibrium. Equilibrium meaning if we all do the same thing together, that produces an outcome that doesn't give us any incentive to change. That's the idea of a solution. It worked. It's a brilliant strategy. You can teach it. You can make it look mathematical. I was trained as a mathematician. This attracted me into economics. I thought I can make a killing here because I knew quite sophisticated mathematics. And everything in economics is brought into this framework and put through this, I don't want to be disrespectful, but sausage machine is what I would call it, without being disrespectful. Okay, so what we're asking in any situation is what agent behavior, and remember all the agents are identical. They're like the clones in Star Wars, they're all the same. And what agent behavior is consistent with the pattern that behavior creates. Think of it might be cars and traffic. What cars going at what speed would produce a traffic flow where no car has any incentive to change. It has what I think is a rather lovely property. It's any time I look at this, I find it beautiful. It's elegant. It's perfect. You can prove theorems showing that if people behave this way, it'll usually be optimal or very close to optimal. It's very close to efficient, and it's highly mathematical. So you can show off a lot. And I don't want to be, I realize here I'm being a bit cynical about this. I shouldn't be. I want to say that this particular way of looking at the economy, it may be mechanistic. A lot of it was borrowed in the 1800s from physics. But it has allowed us to solve problems of central banking, of macroeconomic behavior. We understand auctions, we understand markets, we understand international trade. So it's allowed us not to do stupid things like put tariffs on other countries, or to mention but a few. So we really understand large parts of the economy, and we're not having these massive collapses like we had in 1929, 1930. So again, this way of looking at the economy has achieved a lot. And of course, there's a but. The but is in large print here. There's a big but, and that is that equilibrium, it's an assumption, and puts a very, very strong filter on what you can see. So we're only going to look at equilibrium situations and say, all right, I've made that agreement, but here's what it rules out. There's no scope for adjustment or for exploration or for creating startups or from any phenomenon in the economy like bubbles and crashes, because they appear and disappear like clouds in the sky. They're not equilibrium. There's no structural change. That's not equilibrium. There's no innovation. And if everything is the same over time, time sort of disappears and there's no history. There's no path dependence. So economists, certainly in the last 50 years, have begun to question this. And they're questioning its reality. We kind of get it, but it's a Platonic universe here. It's not that real. They're questioning its authenticity. And if I talk to somebody like John Holland, that I talked a lot with in the early days, as Eric mentioned, any idea of equilibrium, John just said flatly, is dead. So the question is, isn't the economy much more alive, more vital than this? So, fair enough. In 1988, the Santa Fe Institute, I have to point out, was in the old convent on Canyon Road. And Santa Fe Institute was a startup. Kenneth Arrow brought me there. He brought several other economists there. Phil Anderson in 1987 And Arrow had brought some physicists and scientists to meet their counterparts in economics. One of the people on the scientific side was John Holland. Another one was Stu Kaufman, actually. There were quite a few people. David Ruel, mathematician. Don Farmer, who should have been here, and others. On the economic side were Larry Summers and Tom Sargent, again, a number of other eminent economists. So the two groups met and compared notes. It was extraordinarily successful. This went on for 10 days. We all got a kind of sugar high on the ideas. And the Institute, after this very famous conference, decided it would start its first program that was going to be funded by Citibank, by John Reed. Arrow and Anderson and David Pines would be the godfathers of this. And they asked John Holland and myself to run the program. John couldn't get away from Ann Arbor, so I was brought in. I had a sabbatical from Stanford and was brought in to run this program. That was the good news. You know, Brian, you're running a program on the economy as a complex system. You're going to have the equivalent of maybe $1 million or $1.5 million, which allows you to buy out quite a few people on sabbaticals. You can have Arrow and Anderson do the inviting, so nobody's going to say no. You can bring them all to a convent in somewhere in the middle of the Rockies. They can all think what thoughts they want, and nobody's going to object. This is a highly isolated place, and nobody's going to know what you're doing. There's a problem. We all got there, and the problem was when we had assembled the masses, what on earth were we going to do? Now, this is 30 years ago. I remember Ken Arrow saying, well, we could do something on chaos theory. That sort of sets the time. Or I was thinking we could do something on network effects or increasing returns, but I'd already spent many years doing that, and I was a bit tired of it. We had other people in probability theory. We thought we could take spin glasses or something from physics and translate that into economic terms. Nothing was quite settled, and this went on for about a month. We would meet in the kitchen of the old convent. We'd have coffee, and we were sort of saying, okay, what's the theme going to be? What's the direction going to be? And strange to say, it was someone who didn't know anything much about economics, Stuart Kaufman, who kind of gave us the lead. One morning, Stuart just said, you know, I'm listening to all of this, he said, but you keep talking about equilibrium. It's like a spider's web where everything's in equilibrium, the economy. But what would it be like to do economics not in equilibrium? So I tried to shut Stuart up. I thought this wasn't a very good idea. This is freaky. We weren't going to mess with that. It was a kind of third rail in economics, and I didn't see how we could do it. But it planted the seed. It was like one of these black seeds where you didn't quite know. It started to grow in my brain and in other people's brains, and we started to think seriously about it. Let me show you for a moment what it's like to think outside equilibrium. It's a realistic situation. I just had in mind what's a typical problem, say, these days in Silicon Valley, where I work. Maybe you're starting up a company, or several companies are starting up something in autonomous trucking industry. So they're going to have fleets or convoys of trucks rolling across the country, and they're trying to figure out how to strategize, how much to invest, what the technology should be. In a case like that, it's not at equilibrium. The companies don't know what they're going to face. They don't know the technology, how it will work out. They don't know who the other players are going to be in this business. Could be Amazon even. Could be Google, more likely Google. They don't know what the reception is going to be for this new technology. They don't know what the regulations are going to be, the legalities, the insurance things. And yet, they're in a position where they have to ante up maybe 2, 3, 4 billion just to sit at this casino table and play. Now, an economist would say, well, that's not a question of probabilities. In a situation like that, there's what economists call fundamental uncertainty. You simply don't know. You're in a position where you don't know, therefore such a problem is not well defined. If you don't know what situation you're in, there isn't a logical solution because you simply don't know. It's not a question of probabilities or a question of lack of mathematics. If the problem is not well defined, rationality is not well defined. There's no optimal solution. You simply don't know what you're facing. So rationality isn't well defined. Deductive behavior isn't well defined. An economic model that works on rationality and deductive behavior is not well defined. And it's highly unlikely to be in equilibrium. I might sit down with my venture capitalists, say, okay, I think I'm going to do this. Some other company does that. Some other company is cash rich and it does something quite different. But it's very unlikely that we're going to hit any form of equilibrium. I'm illustrating this because I remember sitting in Santa Fe in the early days, and I'm saying to Ken Arrow, we should do something out of equilibrium, Ken. We should do something that has fundamental uncertainty. Don't you think that's important? And I remember Kenneth Arrow, who was our godfather and certainly, I think, one of the very top theorists in the world, if you could argue, certainly the top one. Ken looked at me and he said, I realize these are huge problems. He said, but what can you do about them? So this is where we were stalled. And then enter a rather modest, diminutive man that I was sharing a house with called John Holland. Now, I only knew I had this house Santa Fe Institute had rented for me. I knew I'd have a housemate. It turned out to be John Holland. I had no idea what he did. I had no idea that he was a large figure in computer science. But John taught us something. And John, I'd had a lot of discussions with him late at night over beer. And I remember John had an important clue. And I know exactly when it happened. In 1987, when we held this big symposium, John gave a talk in the afternoon. And I listened, and he was on about genetic algorithms and classifier systems and how to teach machines to get smart, how to write algorithms that could change their code. We now call this evolutionary programming. John had all this down, and I'm sitting there thinking, there's something here we need to pay attention to. And the nearest I got to figuring out what it might be was just a hunch. I sat there thinking, if John Holland is the solution, what is the problem? And here's the problem. John was pointing out two things that people, or if you like, automata, algorithms, whatever, they can act in situations that are not well defined. This is mind-blowing in the social sciences. Of course we do that. We enter contracts like marriage, not well defined. We decide we're going to get into whatever. Buddhism, we don't know what that is. We do these things all the time. And John was pointing this out, but I'd been overeducated. And how do they do that? John says, well, they make sense, they experiment, they explore, they adjust, they readjust, but not just in terms of having some wondrous mathematical model of the situation and updating a parameter or two. They take in a hypothesis, they throw out the hypothesis, the multiple hypotheses. I was working at the time for Citibank in Hong Kong in the analytical division. I had a team and we were trying to crack the foreign exchange market at 3 in the morning when all the play was happening. And we were using what now would be called AI, neural nets, etc. This is a long time ago, close to 30 years ago. But it was all making sense. And I noticed that the actual traders had hypotheses. Oh, such and such has just happened. This Central Bank of New Zealand has just come into the market, but hang on. I think the Chinese are going to do that. And if the Chinese central bank does this, then that's going to happen. But then something else would happen. They'd throw out that hypothesis and take in others. John was explaining all of this. And the big breakthrough is we realized we could do this. In economics, we could look at problems that were not well-defined, problems where there's fundamental uncertainty, problems when there is no equilibrium, and we could unleash agents that could explore, take up hypotheses, throw them out, and so on. Now notice one thing as well, these very actions of exploring, changing, adapting, experimenting would further change the outcome, and you'd have to then readapt and readjust. So you're always adapting and adjusting. I remember being asked very seriously in the middle of a talk like this. Somebody put their hand up. They were middle-aged. And they said, you know, after all this talk, Professor, how would you define complexity? And it's a fundamental question. I'm sure David's had to face this. We all have 1,000 times. Right on the spot, I said, have you ever had teenage children? You get the whole thing. Actions, adjusting, exploration. There's no optimal solution. You're coping, you're rebalancing, you're threatening, you're rewarding, whatever. But that changes the outcome, and then you have to change, etc. It's a bit like surfing, if you've ever done that. So this lands us in a world where forecasts and strategies and actions, whichever you're using for that sort of situation, are getting tested because they don't last if they're no good. So they're getting tested within a situation, I would like to call it an ecology, those forecasts and strategies and actions create. And that's, if you look at it that way, that's the very essence of agent-based models. One definition I have of complexity economics, by the way, I gave it this name in 1999. I was publishing a paper in Science on complexity and the economy. The editor called me from London and said, you need a name for this approach. I said, no, I don't. Yes, you do. No, I don't. He prevailed. I said, call it complexity economics. I thought it should have been called non-equilibrium economics afterwards, but it was too late. It got locked in. Complexity economics is basically seeing the economy not as a machine, balanced and perfect and humming over, but as an ecology. New strategies, new things are coming and going. And it's one in which the behavior, if you like, of the species or the strategies could be described algorithmically. Now, I want to make a distinction here. I'm not saying that all the human beings are agents in a particular situation or algorithmic, so they're walking around like these robots. I don't mean that. I mean something more serious than that. If you describe something algorithmically, you can allow verbs. So complexity, if you like, is allowing science to have verbs as long as you can use algorithms. They can buy, they can sell, they can change their minds, they can throw things out. These are actions, these are verbs. It's not the level of prices, the level of this, the level of interest rates. You get real verbs happening, and this could be quite complicated, and the situation may show perpetually novel behavior. Another thing we learned from John. I'm getting a bit short of time, so I'll go a bit faster. What difference does complexity economics make? I think people who are in this business would all have a different answer to that. But I want to just point very quickly to three areas. One that I think is underestimated in the economy is the persistence of financial crises. I got this off the internet. I don't know the proper source, but it looks reasonably correct to me, and I'm a theorist, I'm not empirical, that's all I'll say. But notice this, around the Depression time, there's a large amount of financial distress over in the, I don't want to call it the post-Reagan era, let's just say the 1990s, 1980s, more financial stress, more and more. Contrast this with this. These are the number of fatalities to passengers on jet aircraft. In 1946, so around 1950, it's about 45 per whatever million passenger miles. Now it's 15 in that, and that was 10 years ago, so it's probably down to 4 or 5. In other words, seismic codes, passenger flying, cardiac situations have all improved. Your pet's health outlook has improved. What hasn't improved is financial crises, and I want to, I'm just enumerating some of them. Russia's Big Bang around the early 1990s. They decided that Russia should go capitalist, or to go back to Berkeley, Russia, or Soviet Union, Brian, we want to have proper capitalism in Russia. And that's fair enough. They went capitalist, but on an equilibrium basis. Old socialist planning equilibrium, new capitalist equilibrium. You can see the results of this in the mortality statistics. There was vicious mortality for 5 or 10 years because they got it wrong. We freed up the electricity market in California in the year 2000. We had Wall Street crash in 2008, et cetera, Iceland banking thing. Here's a question. Economists are not stupid. I say that very sincerely. They're smart as all get out, so why don't they anticipate these disasters? I wondered about this for a long time. The answer is some of them do. Economists quite often will say, we don't like the situation. We have this mortgage-backed securities market in New York or wherever it was in 2008. We don't feel quite good about it. But why doesn't the profession as a whole have something like failure mode analysis or forensic economics? There's a syllogism. If you assume equilibrium, which economists do, at equilibrium there's no incentive for any agents to diverge from their present behavior. That's logical. That's the definition of an equilibrium. Therefore, exploitive behavior can't happen. And all these systems were exploited. Anytime you see a financial crash, you'll find a small group exploiting the economy. Complexity economics, on the other hand, sees the economy as a web of incentives for novel behavior. It sees the economy as open to new behavior, and that might be exploitive behavior or gaming the system. And it starts to ask, what's the likely response going to be? Can someone game the system? I'll go over this very quickly. I notice I'm out of time. Second thing that I think is very important that complexity economics could help a great deal with is an awareness of the propagation of change. If you're only looking at equilibrium, there isn't any change. There isn't any propagation of change. But as we heard in one of the previous talks from Matthew, banks, or sometimes people, or networks. They can affect each other. Banks in distress can affect other banks. If I owe a lot of money to some bank and I'm a bank, then and if I'm in trouble and fail, then I pass on distress to my creditor bank, so they can pass on distress to counterparties. And stress can cascade through a system like this. Failures can cascade. One of the great things about complexity is we understand this sort of thing extraordinarily well. The third thing is that, and this is a bit more subtle, we can connect with the insights of political economists. Let me explain this one. It's not obvious. But I realized quite a while ago that in economics there's two large groups of problems. You could call one allocation problems. That's international trade theory, strategic outcome theory or game theory, general equilibrium theory, et cetera, those are all well understood. The other questions are questions of formation. How do economies develop? How do they come into being? How does innovation work? How do institutions change things? Where do institutions come from? And so on. Structural change, how does that happen? These latter questions are all the ones that complexity economics can look at. The former questions are all the ones that algebra and calculus and differential topology, whatever, can look at. These have all been mathematized, the ones at the top. None of these have been mathematized for all the reasons I've been giving you. But there's a huge amount of lore on them from people like Thorsten Veblen or Josef Schumpeter, von Hayek, George Shackle, and others, many others. These were people who thought about those questions of formation but had to think qualitatively. They couldn't mathematize that, and I'm not saying we should. But now we have rigorous tools in complexity economics where we can look at these questions of structural change and formation, and we can metaphorically meet up with these more wordy economists and learn a lot from them, and they can learn from us. Let me close with some thoughts here, and just 3 thoughts. Standard economics is very orderly. There's no word in English that I know, but I was talking to someone a little earlier who's German. So in English, in German you say, das ist schön ordentlich. Schön ordentlich means sort of God-given order, not just order. So standard economics likes a sort of God-given order. Problems are well defined. It deals in terms of deduction. There's a stasis, times absent, and so on. Very, very much a 19th century approach to science. The outcomes, the solutions are pristine, pure, artificial in a way, and elegant. And my metaphor for that is it's like an ice palace. You don't want to lurch, get drunk, and knock against some column or the whole thing might fall down. Complexity economics deals with contingency, historical contingency, path dependence, indeterminates, etc. It's organic, one thing building on top of another. It's highly algorithmic. This affects this. It's a cascade of events triggering other events. And to use a term of the architect, if I can get his name, Robert Venturi, it's full of messy vitality. If you want, this is Apollonian. This is for Eric Beinhocker. Eric mentioned philosophy. This is Apollonian. This one's Dionysian. I don't know. So that question, is it just a bolt on to standard economics? Absolutely not. It's a more general theory because non-equilibrium includes equilibrium. So it's generalizing the whole equilibrium thing. Does it go with the zeitgeist? I would say yes. all the sciences from roughly 1900 to about the time of quantum, the earliest ideas of the quantum, to about now, there's been a shift, and this is my own opinion, from order, determinacy, deductive logic, formalism, and so on, to much more organicism, contingency, indeterminacy, behavioral reasoning. There's a lot of reasons for this. Part of it is the rise of biology as a very serious science, and molecular biology, and computer science, and new types of mathematics. And by the way, one of the symptoms of this is complexity. It's not quite a cause of it, it's more complexity. Let me finish with what I think is a rather beautiful allegory that David Collender has given. Dave Collender says that imagine that around 1850 all economists gathered together and they're at the foot of two huge mountains, and they decide they want to climb the higher mountain, but both mountains are in the clouds, and they can't see which one's higher and which one is not. And so they decide to climb the one that's more accessible, the one that can get their equipment through to, and the one where the foothills are better known, so they climb the mountain of well-definedness and order. They get to the top of that and they're above the clouds, and they say, oh my God, holy shit, this other mountain, the one of ill-definedness and of organicism, is higher. That's the one we are starting to climb, and it started here. Thank you very much. I'm happy to take questions if no one else.
Alex says, third point, I'm the macro strategist. One question for you on the point about financial crises. You said there's always a small group of actors that create the crisis. In the case of the 2008 financial crisis, who do you think that group constitutes?
Well, you have experts here. Bill Miller's here and a number of people who were actually, if I may say so eloquently, engaged in the situation. They certainly didn't cause it. But I don't know, I would say AIG, Lehman Brothers, and so on. What really caused this crisis, I think, and you could go back in the causality, who were the people who allowed really good credit ratings to what turned out to be rather worthless products, derivatives. I don't know, and I don't know why that happened. Turns out that Doan Farmer and some other people, I think Rob Axtell, who's in the audience, have been looking at the whole history of that and redoing it. What interests me, so I don't know this history very exactly, but there are a number of people in the audience know it exactly. What I would point out is, I'm trained as an engineer, and when I was thinking about complexity economics, I read a lot about failure mode analysis in aircraft. What you find out is that there's always some tiny crack appears, there's always some tiny event that triggers another event that might trigger another event. Nearly all the time, nothing disastrous happens. But sometimes these events triggering events lead on and disaster happens. Why should complexity economics be any better looking at things like that than static equilibrium economics? Complexity economics is a way of looking at the economy based on events triggering events. So it's natural language is that. Static economics, equilibrium, you could say possibly, well, there's one equilibrium, the aircraft is flying very nicely, there's another equilibrium, it's on the ground in pieces. But you can't, it doesn't give you any feel for this triggers that, that triggers this. And there's might be a whole Boolean structure. If this fails, that might not fail. And if that doesn't fail, this will not fail. But the two things not happening might trigger something else. This is what complexity is good at. Let me say one other thing here. Standard economics is a science based on nouns. I mentioned that a moment ago. Look at anything in the economy that's tracked. Housing starts, prices, quantities sold, interest rates. They're all nouns, rates of this, quantities of that. Complexity allows you to say, oh, this agent is buying, this agent's forming new expectations or new forecasts. This forecast is showing this, and that's causing that attendance at some bar in Santa Fe or whatever it might be. So complexity allows us to think not just in terms of nouns, but in terms of verbs as well. And I think this is happening in all the sciences, especially it's happening with respect to our moving from just pure algebra-based equation systems, that's my training, I'm not against it, to more algorithmic thinking of this, triggering that. So this is a deep change, I think, that's happening across the sciences, and it's really available to us because computation's available. Therefore, algorithms are available. Therefore, verbs can be added in our model. Yeah. I can't see with the lights.
Hi. Thank you very much. Vitalik Katsanolson. I'm a value investor, and my question is, investing for the last 30, 40 years been dominated by modern portfolio theory, where there is an assumption basically that people are, there's a lot of similarities because modern portfolio theory can be taught by a physics teacher, 3 days after he studied the text, which is much more difficult to be taught by a practitioner. But my question to you is, there's an underlying assumption in modern portfolio theory that people are rational, and that seems to be the same assumption in the traditional economics. Is that so? Are there similarities you see between modern portfolio theory and traditional economics? And maybe there's, that's.
It's something like this that I spent time actually with Blake LeBaron, who's in the room, and John Holland and some other people looking at what's called asset pricing under conditions where people aren't necessarily rational. They're exploring and trying to find out how the market works. Sometimes I would say, and I don't know if this is a very good answer to your question, but sometimes standard economic theory works very well. Harry Markowitz was the guy who cooked up portfolio theory, I think as long back as the early 60s, or maybe even earlier than that. Sometimes you can think in terms of rational players, and you can think of probabilities of what earnings might be, and you could think of diversifying among stocks that are not that correlated. In practice, and again, we have several experts in the audience who have years of experience, but in practice, when things go really right or really wrong, it's usually events triggering other events that would not be foreseen, that are part of basic uncertainty or fundamental uncertainty. And you could say, well, I redefine that as probability distributions with long tails. But that doesn't quite get to it. And again, I think other people would be much more eloquent than I am. But what I would say is that when it really matters in the economy, it's not a matter of equilibrium. It's a matter of really figuring out this qualitative change causing events that trigger other events, bringing in new strategies, shutting things out, shutting things down. I remember somebody asked me at a lecture, it was in Singapore, the guy, and I was talking about stock market and the Santa Fe model of that, and hand went up and he said, you know, he said, you've said directly in this talk that 98% of pricing can be established by standard economic models, and about 2% of pricing can be explained by these events triggering other events, and bubbles, crashes, and so on. And he said, so we're only off by 2%. What do you think of that? You know, I said, that 2% is where the money gets made. You could equally argue from outer space that the oceans in the world are perfectly at equilibrium spherically, and then try and be in a freighter in heavy seas. So within maybe 50 or 100 feet, the oceans are in equilibrium. But the non-equilibrium part is where the ships are. And that's what counts. It's the startups that make it. It's people who are lucky, and it's not always luck. It's the ability to look forward and say, this might happen affecting that might happen affecting this. You can't get that at equilibrium. So. At the back.
Could one argue that in complex systems, like emergent phenomena are a form of equilibrium? Maybe they don't last for a long time, maybe they change slowly, but they are still some kind of equilibrium when you think about like social norms, for instance. It's kind of like a balance between different extremes that eventually they meet somewhere in the middle.
My answer to that is no. That's, I don't want to be rude here. But let me see if I can put this in a context. You can think, as I said, of cars with an equilibrium flow, of cars going down a freeway or interstate. And you could say that in a situation like that, if the cars get quite dense, then an emergent phenomenon is that there might be a traffic jam. A car slows up a bit for some reason, maybe some animal runs on the road, cars behind it slow up, and quite soon there's a traffic jam. Emergent phenomenon. Now, and this is subtle, you could define a stochastic process that was in equilibrium. It's a stationary stochastic process of cars. And you could build in that stochastic process is stationary, and every so often it fetches you up these situations like traffic jams. I'll give you my reaction to that. You can do it, but it's a case of paradigm stretching, in my opinion. Why not just relax and say, equilibrium's wonderful, I'm not against it, it's got a huge amount of economics, it's given us wonderful insights, and there are situations that are not in equilibrium, rather than try and say it's all equilibrium. And by the way, papers do get published all the time doing the latter thing. Let's define let's take this non-equilibrium traffic jam situation, we'll stuff it into something we're going to call an equilibrium, and they'll publish it. Not a good idea. Okay. Right.
Nancy Hayden from Sandia National Laboratory. So earlier today we were talking about how to build common knowledge. And one of the things that we've struggled with in trying to focus on verbs rather than the nouns is how do you build a common knowledge with the new kinds of analytic frameworks that we have for non-equilibrium that people easily can understand what they're seeing when they're looking at and analyzing these kind of verb type of measures and ways of framing the problem rather than the nouns. And that we have not figured out how to do that easily for just kind of the general common knowledge rather than specialists.
Well, I want to say this, that there was a talk earlier today, Eric Beinhocker's talk, that I thought was absolutely brilliant. And you should go out of the room, Eric, but it was brilliant because Eric was basically saying we need to look at things, maybe an economy, maybe other situations, maybe political situations in general around the world, using different vocabulary, using different types of instruments for looking at that. We need to admit different types of phenomena besides just equilibrium ones. We don't need these Russian dolls of logic within logic within logic. We need to allow that the world is messy, always unfolding, always giving us new things. So it's part of what's happening is that, as I said, I think the entire zeitgeist is changing, meaning that we are starting to look at the world. Let me put it this way. I think we're in the last vestiges of the Enlightenment thinking. David was talking about this a few minutes before my talk here. In the 1730s, people thought everything was mechanism and everything was right and everything was properly ordered. And all nature is but art unknown to thee, all chance direction which thou canst not see, all partial evil, universal good, and so on and so on. That's from Alexander Pope, 1733, essay on man, but basically saying everything's ordered, everything is understandable, if only we could look into it and understand the mechanisms, the art. And that's changed. I don't know whether it's world wars, but more likely it's quantum physics, biology. We're looking now at the world as swirling and changing and contingent and one thing building on top of another. And what David was saying, and I think that the Santa Fe Institute's in a very good position to do, because it's taken leadership in this area. Santa Fe Institute would be in a very good position to say, if there is a new way of looking at the world, which Eric very eloquently laid out, what exactly is it? Where is it coming from? What evidence do we have? And why do we think this way now where we didn't do this 40, 50 years ago? Our outlook has changed. And if we get this change and we understand it, you can bet that's going to affect the vocabulary or the lexicon. I forget the words you used. We will be talking a slightly different language. Does it matter? Yeah. If you think everything should be perfect, if you think everything should be ordered and so on, life gets very brittle. Oh, my life isn't perfect. Things are out of order. I haven't done this properly. I haven't done that. We tend to get nervous. If we say, yeah, it's pretty good, but could be better, and it's one damn thing after another, which is a definition of life, we're okay. We will adapt, etc. People relax. The polity relaxes. Social ethics relax a bit. We're not expecting a very Puritan, ordered outcome. We're just saying, yeah, it's life. And we can accept a lot more. And I think that if there is, and maybe I'm imputing this to Eric or to David, but I think that what we're missing at the moment, and this goes to your comment, we're missing a way of looking at the world where we accept life. And I was very influenced by Robert Venturi's book in 1965. I didn't read it then. It was called Complexity in Architecture. He just meant complication. But he made a huge distinction between what he called the prim dreams of pure order of the Bauhaus, you know, all these geometric, perfect things, versus what he voted for, which he said, what I like is what I like is the ambiguous, the contingent. I get a whole list of things. What I'm for is messy vitality. So I think if there's a message in complexity and in the zeitgeist, it is cool it on the order. Let's just relax into a world of some degree of messy vitality. And for my money, complexity shows us what that world looks like. It's not optimal, but it's pretty damn good. And it's alive.